Okay, now of course we wouldn't be learning the double angle identities if we weren't going to use them to verify some expressions. So we have another trig equation. It says verify that the equation cotangent of theta minus tangent of theta equals 2 cotangent of 2 theta is indeed a trigonometric identity. So let's go ahead and verify this. Now the only thing that I can see with this equation is that it's written in cotangents and tangents. And so what I want to do first is just rewrite it in terms of sines and cosines. On the left, we would have the cosine of theta over the sine of theta, rewriting cotangent, minus the sine of theta over the cosine of theta, rewriting tangent. And that would be equal to 2 times, and I'm going to rewrite cotangent over here. I know that's the cosine of 2 theta over the sine of 2 theta. Okay. Let's look to the left first and let's simplify the left, and then we'll move to the right. Now, if I look to the left, I notice that, and I think I'm going to write it in white right now. I notice that I can make a common denominator here. That's pretty much the only thing I can do with the left is make a common denominator, make this one big fraction, which means I have to use both sine and cosine as my common denominator, which means I'll be multiplying this fraction by cosine because it's missing the cosine piece, both top and bottom by cosine of theta, and I'll be multiplying this fraction by sine of theta, top and bottom. So what I would end up getting on the left is cosine squared theta, and on the right in the numerator I would have minus sine squared theta. So this fraction is sine of theta, cosine of theta in the denominator, and in the numerator we would have cosine squared theta minus sine squared theta. And that's pretty much all we can do over here. Let's look to the right. And remember, we want to get the right, or not the right, we want to get the right looking like the left. And what I notice is the left already has some things that possibly will match based on what I see, like this cosine squared theta minus sine squared theta. That's the double angle formula for cosine. So let's see if we can expand out, because if I notice I have the double angle formula in the numerator for cosine, I can expand out the denominator for sine because that's a double angle right here. So let's see if we can expand it out and see if we can get the left looking like the right to verify this. So if I expand the numerator out, I know that the numerator would just be 2 times, and remember, one of the forms of the double angle formula for cosine is cosine squared of theta minus sine squared theta. Right? Double angle formula for sine, we know that's just 2 times sine of theta cosine of theta. And now I'm pretty good. I'm set. I know the left will look like the right because the 2's cancel, right? And then I'm left with the same thing on the right and left. I verified this. We can move on.